In this example, we're going to solve a cube root equation. So we've got the cube root of 2x is equal to 4x. Now, just like a square cancels out a square root, a cube will cancel out a cube root. So what we're going to do, since we have the cube root on its own, okay, remember that part of it is always vital, you want the cube root part of it to be on its own, we're going to cube both sides. Okay, now you can only do it once you put the cube root part of it on its own. So we're going to have the cube root of 2x, and we're going to cube that, is equal to 4x cubed. Okay, so the cube and the cube root will cancel each other out, and that leaves us with 2x. Okay, now this side, 4x cubed. Let's think about this for a minute. You can do a couple of different things with this. You can move the 3 in here, just use the laws of exponents, and move that in there, so it becomes 4 cubed times x cubed. 4 cubed is 4 by 4 by 4 is 64x cubed. So that's one way to do it. Or a more a way to do it more by first principles, to think about what cube means. It means 4x by 4x by 4x. Okay, so 4 by 4 is 16 by 4 is 64. X by x is x squared by x is x cubed. So no matter which of those ways you choose to use, you're going to get the same answer, 64x cubed. Okay, now there are several things you can do here. One thing to be careful about is that if you divide across by x or by 2x, then you also have to take account separately of the possibility that x could be 0. Okay, that's one of the things to watch out for. So dividing across by an x is a little bit risky because you have to figure out, could x be 0 if you do that. Maybe a safer way to do it would be to move everything to the same side and then factor. So if we move the 2x across, it becomes minus 2x, and we have 0 is equal to, now remove the GCF, which is going to be 2x. So we take 2x out of both of those. 2 goes into 64 32 times, and x goes into x cubed, x squared times, minus 2x is 1. So that gives you 0 is equal to 2x, or 0 is equal to 32x squared minus 1. Now 0 equals 2x if we divide both sides by 2. So divide both sides by 2. 0 divided by 2 is 0. 2x divided by 2 is just x. So 0 equals x is an answer, and that's the one you would lose. You would lose that answer if you just divided it. If you went back up here and divided by, it's just divided by x, you would lose that answer, x equals 0. So that's why factoring is probably a safer way. In this case, we have 0 is equal to 32x squared minus 1. Let's move the 1 across. We want to get the x squared on its own. So let's move the negative 1 across. You got 1 is equal to 32x squared. And now divide both sides by 32. You get 1 over 32 is equal to x squared. And if you take square root of both sides, square root of 1 is, well, let's do it this way. Square root of 1 over 32 is the square root of x squared. Square root of 1 over 32 is the square root of 1, which is 1 over the square root of 32 is equal to the square root of x squared is just x. Remember, one thing I did forget here, plus or minus 1 over root 32. Okay, now some people might insist on you rationalizing the denominator, but there's really no need. That's a fine answer, perfectly acceptable answer. X equals 0, x equals plus or minus 1 over root 32. Now with square root equations, remember, you have to check all your answers, okay? But with cube root equations, we don't need to do that. And the reason is, the checking only comes into play if we raise both sides, see this line here? This line here. We cube both sides, we raise both sides to an odd power. If whenever you raise both sides to an even power, like in squaring, to the power of 4 to the power of 6, then you're going to have to check your answers. But if you're raising both sides to an odd power, there is no need to check your answers, other than to assure yourself that you're correct. But if you haven't made any mistakes in your work, then those answers will be correct. Okay? Thanks for watching.